Alright, friends, welcome back. In the previous session, I introduced you with the predictive analytics, the major components of predictive analytics, and we discussed the data part of it. It was just an introductory discussion where I spoke to you about the types of the data. It can be structured, unstructured, semi-structured, and then I discussed the sources of data from where it can come. All these were discussed. And then we went to the next part of it, models. I stopped it there. We will go detailed in this session on models. Models are nothing but the brain of the predictive analytics. They are the algorithms. They are the brain that can learn, that has the capacity to learn from the data patterns and with which they can generate the predictions based on the data. They are going to learn from the data and generate predictions based on what it has learned from the data. That's all. Alright. We need to understand that a model is like a recipe that can help predicting the future by learning from the historical data or the data that's getting generated. Imagine you are trying to predict how much lemonade you will sell at your stand based on the weather. I am going to give a hypothetical data. Over the past few days, you notice a pattern. On the sunny days, you have sold 50 cups. On the cloudy days, you have sold 20 cups. On the rainy days, you sold only 5 cups. So, you need to now go ahead and predict it. We are going to build the model. We are going to learn from the model. You record the data and recognize that the weather affects the sales. Of course, yes, if it is so chill, people may not want to drink. If it is raining, people may not need it at all. So, more sun, more sales. More rain, fewer sales. That's the pattern that you can understand. Now, next week, the forecast says that it will be sunny. So, based on your understanding from the data, you are predicting that you will sell around 50 cups of lemonade in the next week. So, it's going to be very interesting. I have got the history. I know the tendency of how things will go on based on the analysis that I have done with the historical data, and with which I predict now that I'll sell around 50 cups. Now, we need to break it down. First, the data. Past weather and sales record is nothing but the data that we have in hand. During this season, I sold these many cups. That's the data that we have in hand. The past weather and sales numbers. Now, we need a model. A simple rule or a formula can be sufficient for us here to understand. Sunny day, it's going to be 50 cups. Rainy day, it's going to be 5 cups. That's all. Now, prediction. The future sales will be based on weather forecast. That's all. Based on the weather, we can decide how many packets or how many cups of lemonade can be sold on that particular day. That's it. Why this works or why you need to trust it. The model is actually based on the data. And it is going to find the relationship between the cause and the effect. What is the cause? The cause is nothing but the weather. What is the effect? Effect is nothing but the sales. So the connection between the cause and effect is properly established, and that's why this can be trusted. This will certainly work is the belief that we gain because it is more logical. The more patterns the model learns, the better could be the prediction. More the understanding, more the data input, better could be the understanding. It is like you and me. More we read, more we listen, we will become much better in that particular area which we are trying to prepare ourselves. Now, we'll have some fun facts. There are 3 types of lemonades available. One is traditional. This is pretty much Indian. Made with fresh lemons, sugar and water. We call it lemon juice here. Sparkling lemonade, carbonated for a fizzy effect generally, and this is not mostly used here. Pink lemonade, sometimes colored with fruit juice, and they make it a little colorful and fun added there. Alright. It's time that we get into types of models. First one is statistical models. Inside the statistical models, we have got linear regression, logistic regression, and time series analysis. We'll discuss more on this, and for people to know a little bit deeper on linear regression, logistic regression, I taught them in my machine learning playlist where you can refer it. The linear regression will help you in predicting numeric values based on the relationship between variables. The input and the output relationship will be connected, and based on the prediction will happen. Logistic regression is always binary, spam, no spam. disease, no disease, fraud, no fraud, yes, no, that's all. Time series analysis forecasts the future data points. For example, the stock prices, the sales forecasting, all these things. It's all about future. Then we have got machine learning models coming into picture. We have got decision tree, random forest, neural networks. Decision tree is more hierarchical in nature and that help you in classifying data. A random forest is all about connecting multiple decision trees to increase accuracy. Neural networks mimics the human brain. It's going to be complex and it's going to mimic the human brain where neural networks will be working that way. And it's for complex predictions. So we've got decision tree, random forest and neural networks. Followed by that, we've got deep learning models. You can use the deep learning for image recognition, NLP, high dimensional data. Wherever it is getting more and more complex, where you need to use neural networks, where you need to deploy neurons to find out the relationship and predict the output, we will call it deep learning model. That's all very simple. And then comes prediction. We will discuss this in the next session. We have seen the data, we have seen the models. Next comes is prediction, and we will talk about it in the next session. If you like the channel content, kindly subscribe and encourage us. If you have any questions, please post it in the chat. We will be happy to answer.